Hello and welcome back to Beginning Java Programming. This video we're going to be looking at branch statements primarily and kind of how we use them in our programs. They're always associated with this keyword if, basically how to get lines of code to execute based on the conditions that are present at the time the program is actually running on the user's device. But in addition to that, at the very end, we're also going to talk a little bit about formatting our strings when we print stuff out for, I don't know, maybe you want to use currency or something like that. You want to make sure you always have two decimal places after, the decimal point. Something like that, right? We can format our strings the way that we want them. So we'll talk a little bit about the printf function. And then finally, we'll talk about random numbers and how to generate random numbers, because that will be a big part of one of your projects. But also, it's just fun. It makes it so that we can actually create some sort of game type programs, which will be a lot more fun than just stuff that calculates how much tip to leave the waitress after you buy a meal. So anyway, let's get started with branch statements. So like I said, branch statements are a way of being able to execute code conditionally. There actually used to be an app for iPhone, maybe also for Android. It was if this, then that. And they just use the acronyms for those words. But basically it was like, hey, if I ever take a picture, I want you to automatically upload it to Flickr. Or, if I get an email with an attachment, I want you to automatically do this to the attachment. Basically, if a condition exists, I want you to do something with it. And so that's the heart of branch statements. The most basic branch statement we have is an if statement. Basically just saying, hey, if this thing is true, then I want you to execute this code. And we'll jump into IntelliJ here real soon. But that idea of sort of conditionality, it allows us to make decisions, right? Like you as a programmer are writing a program, months, years before a user actually uses it. And so you don't know what's going on at the time, right? You don't know if the user maybe wants to select a particular thing or they want to do whatever. Based on whether or not you liked this person's post. What sort of posts should I show you in future, right? Should I show more of, posts from this particular creator or not? All of that is happening, based on logic. It's conditional based on what is actually happening at runtime. So basically, if statements allow us to be able to make decisions. And all of them are going to involve these conditional statements, right? These conditional statements that are going to translate into a Boolean value. Booleans, if you remember from type, and I know I went through it really quickly with type, but a Boolean value can only have one of two values. It either has to be true or false, which means that these conditional expressions have to eventually evaluate to true or false. To start with, we're going to use maybe one of these comparison operators. Remember, I at some point had said 2 plus 3, that expression has a numeric value, it has an integer value, the value 5. But 2 less than 3 has a logical value, a Boolean value. It results in true. 2 is less than 3. 2 less than 2 results in false, because 2 is not less than 2, they're actually equal. And so these sort of basic comparison operators are really helpful when trying to create stuff, right? We've got less than, greater than, less than or equal to, greater than or equal to, which will return, true if it's less than or equal to, if the value on the left is less than, or if the value is equal to. And we do those in two separate symbols, right? We do less than and equals to, and then greater than and equals to, because we don't have that little symbol with the less than with the line underneath it. It just doesn't exist on the keyboard. So we use two symbols to represent that single operator. Another one that we use two symbols for one single operator is the equals equals operator. That is actually the check for equality. Remember, the single equals is a assignment operator. It assigns a value to a variable. Equals equals will compare the two values on the left and right and return true if they happen to be the same value, right? After you evaluate whatever expressions might be on the left and right. Because remember, you can actually have full expressions on either side of these operators. Those expressions will then be compared, and the entire result will end up being either true or false. There is a symbol that you'll have to get used to, which is probably the newest one you'll see here, which is sometimes called the bang operator, I think because the term exclamation point has way too many syllables in it for anybody in normal conversation. So in IT circles and computer programming circles, people will just call it the bang symbol. It's the exclamation point. But that generally has the meaning of not in computer programming. And so bang equals just means not equals to. So, 3 not equal to 3 would have the value of false because 3 and 3 actually are equal. And so long as the two values are not equal, that will return true. But these are sort of your basic mathematical operators. Now you can also combine your conditional expressions into larger, more complex conditional expressions using these logical operators. We've got 3 that we're going to look at, and, or, and not, but they pretty much allow you to just create larger things, right? I only want to give this particular vaccine to people who are age greater than 65 or age less than 18, right? I want to give it to the young and to the old, but people in the middle I don't really care about so much. Or I do, they're not maybe at risk for something. And so in this case, I would want to connect those to an or, right? If you come by and you say, oh, well, my age is 43, you would say, well, is the thing on the left correct? Or is it true? No, you're not less than 18. Is the thing on the right true? No, you're not greater than 65. So both this is false or false. This is going to be overall false. And so we have 3 of these operators we want to look at. And, which is represented by 2 ampersands, or, which is represented by 2 pipes. Now, pipes are going to be that key that's above your enter or return key. It's above the backslash. On some keyboards, it may actually look like 2 vertical lines, one on top of another, but it's the pipe operator. Anyway, 2 of those side by side. And then the not, which actually doesn't compare 2 things, or doesn't combine 2 things. It just reverses the meaning of whatever comes after it. And so we'll look at some truth tables here. So a truth table is basically a way of looking at these as inputs. They're popular in circuit design. And the idea here is that if you think of this statement, right, if you clean your room and you make your bed, then you will get ice cream, right? I've taken 2 separate statements that could be true or false, right? Did you clean your room? I don't know. That could be true or false. Did you make your bed? Well, that could be true or false, right? If I connect them with an and, I get this larger expression, a more complex expression, right? And for and, both of those things, right? You can think of the first thing as input A and the second thing as input B. Both of those things have to be true in order for the entire thing to be true. So your mom comes to you and says, hey, if you make your bed and you clean your room, you get ice cream. If you make your bed but you don't clean your room, you don't get ice cream. If you don't clean your room but you do make your bed, you still don't get ice cream. If you don't do either, well, certainly you're not getting ice cream. But if you do both, then you do. It's the only time that you do, because we connected it with an and. Or is a little bit misleading in English, if we're honest, because or has a couple different meanings. In fact, in circuit design, we would have or, which almost always means inclusive or, and XOR, which means exclusive or. So we mean the inclusive or here, which is to say that the thing on the left can be true, or the thing on the right can be true, or they can both be true, but just something has to be true. The only time you have a statement involving or be false is when both the thing on the left and the thing on the right are false. Then the entire thing is false. This is the inclusive or, right? If I were at a store and they said, oh yeah, we accept cash or check. Okay, so I owe $20. Can I give you $20 in cash and no check? Well, sure. Can I give you a $20 check and no cash? Sure. Can I give you $10 in cash and a $10 check? Well, sure. It's fine. What if I can't give you anything and I offer you a Visa card? Well, no, because we only accept cash or check, right? Like in that particular case, the only time it would be negative is when you have false on both the left and right of the or. Exclusive or, by the way, is more like when you go to a restaurant and they say soup or salad. The idea is that you can have the soup or you can have the salad, but you can't have both, right? I'm making you choose. It's this or that. And in fact, in that particular case, it would have to be the soup or the salad. You can't have both, and you can't decline. You have to have one or the other, which would be kind of a weird restaurant. But anyway, we're not dealing with exclusive or this time, so we're fine. The other one is not, which just changes the value of whatever happens afterwards, right? If it's, you have a statement, then you say not, it just reverses it. So not A, if A was true, it has the value of false. If it was false, it now has the value of true. It just reverses the signal. It reverses the value of the Boolean. And so the analogy here would be the 90s sitcom trope, just saying not at the end of something, like, oh, that's a lovely sweater. Not, oh, okay, see, so that was a compliment. You were complimenting my sweater, and then you said not, which means that, no, you actually think my sweater is ugly, right? You just reversed the meaning at the end. In this case, we reversed it at the beginning. But, oh, you're a real idiot, not, well, I guess then that actually means that it's a compliment, right? You were insulting me, but then you said not, so that means that you must think I'm actually quite smart. Anyway, basic logical expression operators. Let's actually get into using them. All right, so here I have IntelliJ open to our standard default template, and I actually want to use some if statements. So let's create something here, shall we? Let's see here. If I do something like, how about int age equals 43. Let's actually kind of, program something. So let's see here. If, and so the keyword here, if, is going to be followed always by some sort of a conditional expression in parentheses. And that expression is going to be evaluated to a Boolean, a true or false value. Has to be something that's going to be true or false. So here I'm going to say if age is under, 30. So that expression, age less than 30, we can evaluate that. We'll evaluate to either true or false. I can then put in some curly braces. These curly braces are going to form a block of code. If I only have a single line of code, strictly speaking, I don't need them, but I'm going to put them in anyway because they never hurt. In fact, Google requires them even if you are using a single line of code. It's just part of their style guide. And so the idea here is that I can now put any code I want inside of those curly braces, inside of that block of code, and this code will only be executed if the age is less than 30, right? And so if your age is less than 30, I'm going to S out, I should say, which is, again, just the IntelliJ shortcut to get system.out.println. And I can print the line, let's see here, Taylor Swift. Basically, I am trying to create a program here that will guess, based on your age, who your favorite artist is. All right, and so here I've got, if you're less than 30, Taylor Swift is your favorite artist. Let's see if this works for me. I'm going to hit play, and after it builds, hopefully we will see that it doesn't print anything. And it's not going to print anything because I'm 43. Age less than 30, I'm not less than 30, and nothing prints, right? That line of code was protected by the if statement. It's only going to execute if the age is less than 30, which is a shame because honestly, I loved Folklore. I think it's a great album. Anyway, there is no algorithm that works to determine people's preferences. So let's say that this is an average student. So the average student would be 19, let's say. I do that, and we get, drum roll, after it finishes building, we see that it does print Taylor Swift, right? And so here, I'm either printing a value or I'm not printing a value based on the condition of your age. Let's make this a bit more complex. So you can actually have more than one branch. Now, if I were to do this, let's say age less than 50, right? Here I'm going to use my S out shortcut again, and I want to say Nirvana, right? So if you're age less than 50, your favorite band is going to be Nirvana. Now, what's the problem with this, right? If I were to do that and I were to run this code, for my average 19-year-old, your favorite band would be Taylor Swift and Nirvana. Well, now, why did that happen, right? It happened because these are two completely different statements, right? These are two completely different branches. One will execute so long as the age is less than 30. The next one will execute so long as the age is less than 50. Well, in the case of 19, both of those things are true, right? But what I really want is for somebody between the age of, if you're over 30 but under 50, Nirvana should be your choice. So here's the problem that I've got. There's a couple different ways I could do it. I could, if I wanted to, actually put that in. Age greater than or equal to 30 and, ampersands, and age less than 50. And this would actually give me the behavior that I want, but it's a lot more complex than it needs to be. What I could do is, instead of making these two sort of, when I think of an if statement by itself, I'm kind of using this sort of like a road design, right? This is like traveling along the freeway and you see a vista point or you see a rest stop. It's like you could exit and do a little something, right? Use the restroom, take a nice picture in front of a scenic view, and then you get right back onto the highway where everybody else, where you left off, and you keep going. It's sort of like, hey, if this is true, go do this thing, come right back to exactly where we were, and we'll continue execution from there. But there is no this or that, right? In order to do that, we can use something called else if. So else if makes this not a vista point. This makes it a fork in the road, right? Kind of. There's actually still a way you could not take either path, right? If age is less than 30, your favorite band is Taylor Swift, or your favorite artist is Taylor Swift. Else if age is less than 50, your favorite artist is Nirvana. The difference between the first one and the second one is that because this is a fork in the road, it's the same decision. If you match the first one, you're out. You no longer check any of the ones that come after. Any of these other else ifs, you don't check any of them, right? And so I've essentially eliminated everybody 29 and younger after that first if, because your favorite is Taylor Swift, right? And so for me, well, actually, for right now, we'll start with the 19-year-old. For the 19-year-old, your favorite artist will be solely, once it builds, Taylor Swift, not Nirvana. You were eliminated with the first one. You never got to the second one. And notice it goes in order. The first one you match is the last one you do. I execute that code and no other code. If I did want to somehow have you sort of back into the fold, well, then that would be that separation where I have two different ifs, right? And I can actually have two different ifs with their own else ifs, etc. Now I could actually create a default case. That would be an else by itself. An else by itself is still part of the same decision. Now we have three branches, and now they are mutually exclusive. There is no way to avoid one of these three branches because I have a default case. If you don't match the first one, you don't match the second one, everybody matches the last one. And that's why else's always have to be at the end, and else's don't have conditional expressions. This is the default. If you get here, this is your favorite band, which for me is going to be U2. So now, why U2? In fact, I shouldn't do U2. I think I do U2 way too much and it sounds insulting. I'll say Beatles, and then that is everybody's favorite band. And so if you think about this, right, who is a fan of the Beatles in this particular scenario? Knowing that you get eliminated as soon as you hit one and it switches, right? So if age is 19, you match the first one, you're eliminated. Anything 29 or younger, you're eliminated. Anything 49 and younger, because remember, this is less than, not less than or equal to. So 50-year-olds do not like Nirvana in this case, right? 50-year-old doesn't match. It has to be less than 50. So if you're in your 40s or your 30s, then you like Nirvana, right? So because, age kind of stopped at 0, right? It's as low as you can go. If you are a newborn, right, your favorite artist is Taylor Swift, up to age 29, from that point to 50, it's Nirvana, then the only people who would ever match Beatles would be people 50 and over, right? And that's because I put them in order. If you have stuff in order, it makes it so that you're kind of using that elimination mechanic so that you don't have to write a bunch of code where it's like, well, actually, if I wanted this to be, I don't know, people who were in their 60s, right, I would say age is greater than or equal to 60, but then I also have to say that they also have to be age less than or equal to 69, right? So these are people in their 60s who would now be fans of Taylor Swift. And I had to put both like sort of delimiters on the age because I wasn't using that mechanic. I'm not going in order. Actually, I could be going in order if I were doing the greater thans and just eliminating older people first and then middle-aged people and then leaving the default to be younger people. Regardless, I'm going to undo this so that we go back to our less than 30. By keeping stuff in order, it makes it a little bit neater, and you can use that sort of elimination mechanic where the first one you match and they're gone. Now that being said, we can also make these, and by the way, you can have as many else ifs as you want. I could say else if age is less than 60, S out, U2, right? I can have as many else ifs as I want. I can make this, these mutually exclusive branches. I can have as many of them as I want. But this is all going to be one decision. You're only going to match one of these conditionals, or you're going to match the default. So now we can actually use our logical expressions to actually make this a little bit more robust, right? I can actually do it based on other things. So here, I am going to use a string. We're going to say gender, since that is chosen. And we are going to make this string for gender male. Back here, we'll use my demographics information. So I am a 43-year-old male. And so we can kind of make this a bit more, robust. I could sit here and say, I want to compare not only your age, but also your gender. So, and gender. Now, by the way, in Java, I can't use the equals operator to say this. And I'm obviously generalizing Taylor Swift fans. Again, folklore, chef's kiss, right? It's good. But I can't compare strings using the equals operator in Java. Java actually has a set of methods that you can call on string objects. So I use the equals. You notice I have two parentheses here because this outside parentheses, and you notice if I just click it to highlight it, it'll tell you which parentheses it matches. This is just for the conditional expression itself. This one is to send something to this equals function. It's basically I want to determine if the string gender has the value of female. So male, female, whichever we're going to do here. And of course, obviously, we could have other genders. But like this is just going to tell, does that string match this? All right, pull it out so you don't get all the documentation for the equals method. And so that's how we determine. So if the string was female, that would evaluate to true. So now we have age less than 30, gender, and actually this isn't going to apply to me anyway because I did it on the younger person. So let's go back to our 19-year-old. It's a 19-year-old male. And who is their favorite artist? Favorite artist is, I have to increase this so you can see it when it happens, Nirvana. why is a 19-year-old male a fan of Nirvana? Well, it's because even though they are younger than 30, this person is not female, they're male. So Taylor Swift didn't match, or that first if conditional didn't match. The second one doesn't check for gender. It just says so long as you're under 50, Nirvana. So they matched to Nirvana, right? Now I could put other gender stuff in other places. I could even say else if, let's see here, age less than 30 and gender dot equals male, then, right, so then I can do a system out and have my own artist for, younger men, which I guess would probably be The Weeknd. Maybe I'll leave this as an exploration for the user or something, but I'm just going to put The Weeknd in here. Weekend. Misspelled on purpose. So there we go. So now if you're a young female, Taylor Swift. If you're a young male, The Weeknd. And now it doesn't matter your gender if you're under 50 or if you're between, because, well, actually, I guess that's not true, right? Again, very progressive society. If you are non-gendered or anything like that, then you're going to be Nirvana, which I feel like kind of works. But like, regardless, well, everybody loves Nirvana. Maybe that's just because I'm in the Nirvana category that I think everybody loves Nirvana. But you get my point. Like, you can sort of make these conditional expressions a bit more complicated by combining them with and. Now, notice what happens if I do this. Or. And we go back to me. 43-year-old male. And I run this code. My favorite band is, you can probably guess this already, even as it's running, is going to end up being The Weeknd, right? Why is my favorite band The Weeknd? Clearly, it should be Nirvana. And by the way, Nirvana is actually not my favorite band. I was much more into punk, so like Green Day would have been. But regardless, My Chemical Romance? Ooh. I'm pretty sure there are no images of me on the web with guy liner, but I can't be certain. Regardless, why is it The Weeknd? It's The Weeknd because that second conditional says less than 30, which I am not, or gender equals male. Now, every male, regardless of age, is going to have their favorite band be The Weeknd, or favorite artist be The Weeknd. Right? Like, that's just all men. Because you're going to match one of those two sides. And so that is kind of how we use if, else, if statements in Java. And also, by the way, again, that comparison, remember with strings, you have to actually do a method call on the string itself to determine if it equals something. And if you want to, there's also another version. And if you just start typing equals, there's also equals ignore case. Ignore case essentially just means we're going to compare apples to apples. So it doesn't matter if I were to put capital M male here. When I compare the two, I'm going to get the exact same value, The Weeknd, right? Because we're ignoring the case, uppercase or lowercase. All right? So that is basic if statements for Java. By the way, there are two other types of branch statements. I'm just going to mention them really quickly. They aren't always needed. You never need them. You can always use an if and else sort of combination to get these same effects, but they're worth mentioning just in case you see them. One is the conditional operator itself. And so the conditional operator would be something like int credit score, and let's say you have an 820, excellent credit score. Then I could say, I'm just going to use, actually I'm going to use this not to print something out, I'm actually going to use it to calculate a value. So let's just say double interest rate equals, And then here I can actually put in a conditional expression. I often put them in parentheses because the conditional sometimes gets, the order of operations is not as high as maybe other things that you're putting around it. And so here I can say credit score greater than 780. I think that's the beginning of excellent credit. This is not a business class. I mean, technically it's in the business division, but 7 is fine. And so here's the weird thing about the conditional operator. The conditional operator is sometimes called the ternary operator. In fact, I'm going to drop this down to the next line just so you can see the entire thing. Because what it does is it has two symbols to represent one operator. We've seen that before. The weird thing is that the symbols are separate. So it's going to be a question mark and a colon. And the idea is that what comes before the question mark is a conditional expression. Just like we've been talking about, it's going to evaluate either true or false. So then the thing after the exclamation point, the first thing is the value if true. So the value if true would say, oh yeah, if you're going for a loan and you have really great credit, then you're going to get 4%. Colon, this is the value if false. The value if false would be, you don't have great credit, then I'm going to give you 6%, right? And again, this would probably be on one line on your computer, but I have a really big font so you can see it on screen. And so here I'm going to have one of two different values. So now I can actually just, system out my interest rate, and we can see what value we're going to get. We have excellent credit, so we should get the lower value of 4%. 4%, it's parsing, it's doing some stuff, it's building, and yeah, we got 4%. We have great credit, right? That is the ternary operator or the conditional operator. Again, it is this with this, so question mark, colon, and the thing before essentially the colon just separates out the two values. Value if true on the left, value if false on the right, and the thing before the question mark is the conditional expression that you're going to be evaluating to either true or false. That is the conditional operator. You might find some use for it, you might not. Again, you could do this with an if statement. You can probably picture how you would do it with an if statement, but you may see this in other people's code as they're writing, and so it might be a good thing to know. The other thing is going to be a switch statement. So switch statements are, I really associate them with like those old school like menus, like where you get like a text-based menu and you have to choose like 1, 2, 3, or 4. So maybe we do like int choice equals 2. And then the idea here is, and this could be something I'm actually getting from the user using a scanner. I've been just putting values in to focus on the actual branches themselves. But here, I'm going to do a switch statement. And the idea is the switch statement just has to be something that I can compare to. And so it could be an integer, it could be anything else. I'm going to, the way we say this is I'm going to switch on choice. I'm not entirely sure why I put a space there. I don't normally do that. But and then I'm going to have a whole, like this block of code that's going to be executed based on whatever the value of choice is. Switch statements are really kind of clunky the way they're put together, but the idea is that I'm going to have these different cases. So case 1 is going to, if choice was 1, if choice matches this value here, 1, and I could use a character, I could use a string, right? I could use lots of different things. Then if it matches the label, then I'm going to execute this code. So I'm going to S out maybe your balance is ... right? And this is very important for switch statements. At the end of the case, you have to get out of the switch statement. To do that, you use the keyword break. It does not break automatically at the end of a case. It's just the way that the switch statement is actually organized, sort of in like machine code or assembly. You have to put the break in yourself. But you can put in as many cases as you want. Now this is it's going to try to do the indent for me because IntelliJ is very helpful, even though I'm trying to do it manually and it won't let me. You got to adjust these things the way you want. Deposit, ... and then break. In fact, here, I'm not going to do the break. I'm going to purposely ruin this. Case 3, S out, and this is going to be with withdrawal. Sorry, I have to say withdrawal so that I remember how to spell it. This one I will remember the break. And then you can also have a default case with switches, just like you can with an else with the ifs. This one you actually just say default. And so the default's going to match everything, and it's just going to be S out, goodbye, I don't know, something, goodbye is one word. Something along those lines. Right. The default case, by the way, does not need a break. It doesn't hurt if you put it in there. It just doesn't need a break because it's at the very bottom. And so you'll see what kind of happens here, because we chose case 2, right? So what we're going to see printed, we want to see deposit. We're going to see put here is build, deposit withdrawal. And the reason is because I didn't put that break in. So it did successfully, choice was 2, it skipped case 1, it matched case 2, it did deposit. It's like an ATM machine or something. Obviously I would do some work here, not just print out words, but you know, it did deposit, but then there was no break. So it went into case 3 and also printed out withdrawal, and then we got to the break and it exited, right? So what I'd want to do is to make sure I put that break in there. This is a classic switch statement in Python. Like I said, you can have it match anything you want, right? You can have it match a string. You got a lot more option than you do with C++. Not that I haven't compare languages. I always compare languages, but regardless, you get more convenience than you do with C++, but not as much as you would get with Swift. Point being, here we're just going to compare like this literal or this value to this value. And I could do something like this, right? If I did choice -1, like where this was an actual expression, if I did that, then it's going to still try to match a case, and in this case it's going to say your balance is because it matches the case 1. So it doesn't have to be exactly like the literal, it's just whatever this value is, we're going to try and match it to one of the cases. If not, we're going to use the default. If you have a default, if you don't have a default, then we're not going to do anything. We're just going to skip it all. So classic switch and conditional expressions in Java. All right, so next for our sort of 2 little bonus bits here. One is going to be formatting strings. So we have print, which doesn't give you the new line character at the end. It doesn't drop it down to the next line. We have print line, which does the exact same thing, prints something to the screen but drops it down. We also have printf. So printf will print a format string, what we call a format string. And the way this works is you do the same thing, system out, printf, and then in quotes, you're going to have your format string. We'll talk about how to sort of lay that out. And then after that, with commas, you're going to have an argument list. And so basically it's going to be commas and then as many variables as you want, all separated out by commas. And the idea of these variables is that they are going to be stuck into placeholders that are inside that format string. So what is a placeholder? Placeholder is just something, it's like a blank slot, right, that is going to be replaced with a value from a variable afterwards. You can have several placeholders in a format string. They will get placed with the values that you have at the ends in that same order. So if you have 3 placeholders, you need to have 3 variables or 3 expressions, I should say, separated by commas after the format string when you're using printf. The placeholders themselves, though, have a lot of value because you're saying, well, I could do the same thing with just concatenation operators, which is true, you can. What you can't do is really format those numbers the way you want them to be. And so here we're going to look at the different placeholders and what they mean. So %d is a placeholder for a decimal number, which is an integer. I know what you're thinking. Decimal should have a decimal place. Why does it have a d? It should be %i. Technically, decimal is just any number in base 10, right? So weirdly speaking, if you look at the months that we just finished, like October is 8, like octopus, 8 arms. November, like nueve, it's 9. September is actually 7. And then December, which is how you would say it in Latin, would be the 10th month, right? Which we all know is not actually the 10th month, and October is not the 8th month, but we somehow screwed up the Latin, and so December should be the 10th month. January, which got named after a person or a god or something, is the the 11th month, and then February is the last month of the year, which is why February gets the leap. It's the one that has fewer days, and when you add a day onto the end of the year for leap year, you add it onto the end of February, not to the end of December. Anyway, dec just means 10, decimal just means base 10. Okay, that was way too big an explanation. %D holds an integer type number or counting number. %F will hold a floating point type number, a float or a double. Doesn't really matter at this point. We're just looking at the formatting, so there's just two different types of numbers. If you put %, you're going to get that same decimal number, but with commas, like where you would expect to see commas. So you'd have 1,000 would be 1, 3 zeros, right? 1,000,000, 1, 3 zeros, 3 zeros. If you want to specify a minimum space of width, right? You can't really specify a maximum, but you can specify a minimum. You can actually put that in there. What does that mean? So if I do %8D, it means that I'm going to print, because this is the console, so all of our characters have the same width, right? You can picture like slots where these things are going to get placed in. You're creating sort of a field that is 8 characters wide, and I'm going to put that decimal number in there, sort of, I think by default it's right justified. But I guess for your side, this would be the right. But it's going to be placed inside of that field, which is 8 wide. Now, why would I care about putting an extra space before a number? It has to do when you're dealing with tabular data, right? Like you want to create columns of data and have everything line up nicely. So if you know that you're always using, 15 characters to represent the numbers, and so it's like 15 for this number, 15 for this number, 15 for this number, and then you get into the next line, it's 15, 15, 15, you know that your numbers are going to nicely line up in nice columns, right? With the exception of when you overflow 15, you go beyond that, in which case it jacks everything up and makes everything askew because your number took up more space than 15 characters. But you can probably figure that out. If you want to do the exact same thing, but you want to have leading zeros, so for some reason I want to have 6 zeros and then 42, you would just put a 0 in front of the 8, and that tells you want leading zeros, which I don't think I've ever seen used, but you can. If you have a 0.2f, that means that you want a floating point number with 2 places of precision after the decimal point. After that, you're going to truncate, I believe. You do not round off, it truncates. I think. In Java, I think it truncates. I should really look that up ahead of time. Every language kind of does it slightly differently. But in this case, this is money, right? So if you want to do, money, we always put 2 decimal places. Even if they're zeros, you're going to get, 2 points of precision after the decimal point, even if they're both zeros. If you want to combine everything, you can do %, 10.3f. This is just showing combining stuff, right? So this means a floating point number. It's going to have a minimum of 10 spaces of width, so we're going to use 10 spaces to hold it. It's going to have 3 places of precision after the decimal point, and we are also going to use commas for anything to the left of the decimal point, right? Point being, you can kind of combine these placeholders to kind of get the behavior that you want. And then afterwards, you just put your argument list, your variables, your expressions, whatever it is, and they will just float into those blank spots. I'll show you a demo real quick. All right, I know I'm going along, and I know that the next sort of bonus thing with random numbers is going to be more important. So here is just a quick demo here. I've got the cost of a meal. I'm going back to this whole idea of a tip thing. Clearly, I just bought a wedding party, sort of like something at a very nice restaurant in Las Vegas. There was probably bottle service, I have no idea, but I have an exorbitant amount for a reason. I also have decided that the service was somewhere between average and really good, so I want to give exactly an 18.5% tip, somewhere right between 15 and 20. Because of all of this, I end up with a tip amount, cost of meal times tip percentage, what I printed out here just using simple concatenation, that looks super ugly. I did put the $sign here as just part of the string, so that's helpful, but whatever. So that's not really all that great. What I'm going to do is I'm going to uncomment that, recomment this. So now I'm going to use a printf statement as opposed to the print line. And so here I've got my tip amount, $, $sign. And then this is the beginning of my placeholder, right? Percent, comma, so we're going to use commas for the amount, dot 2, so 2 points of precision after the decimal point because it's money, and then F because it's going to be a floating point type thing. Even though it's actually a double, it's still a floating point type number. And then a comma after my format string is done, and then the variable that I want to insert into that placeholder, which is just the tip amount. So now when I run this, I get a nice, clean looking $1,662 and exactly 71 cents once it runs. Promise it's good. Yeah, there we go. See how much nicer that looks? Anyway, printf, kind of helpful if you're needing to format numbers. All right, and so finally we're going to look at how to generate random numbers so that we can actually do some gaming and stuff like that. This is going to be a lot like the scanner, to be honest. It's going to work in a very similar way, except that instead of getting a number or a value or a string from the user, what we're going to do is we're actually going to get a value from a random number generator. Now, it should be noted that most computers, technically speaking, no computer can generate random numbers. It's always going to be based on something. Usually, it's a bunch of really fancy math performed on a number that can kind of be random. Usually, it's the time. And the reason the time is important is because the time for all computers is recorded as the number of seconds that have passed. Actually, I think it's the number of like milliseconds or something that has passed since January 1st, 1970 at midnight, or like the very first moment of January 1st. And so that's just sort of, 1969 is when the Unix operating system came out. That was the date that was decided. That is 0.0. So at that point, number of milliseconds passed. Everything that we do with days, when it comes to the day of the week, the month, the day, the year, the time, it's all the same thing. It comes down to that value. How many milliseconds have passed since January 1970? And so here's the thing. I don't know what that number is. I bet you don't know what that number is. I could probably generate that number right now and I could see what that number is, but when I run the program next, am I going to know what millisecond that was? Right? Like these are kind of a random number. Now the problem is that once you have that base seed number, it's going to end up, there's the potential for finding patterns. The Java random is really good, but there are other better algorithms for it. Basically, in computer science, there is no such thing as a random number. There's just really, really fancy, hard to predict numbers. And yeah, disclaimer. Don't start trying to pull anything in Vegas. You may end up buried outside of the city. But regardless, here we've got an import statement because we need to import another utility. Just like with Scanner, we're going to import random. You can either choose to let IntelliJ do that for you or add the line yourself at the beginning. So import java.util.random. After that, we're going to create a new random generator, just like we do with a scanner. So the type is going to be random. We're creating an object of the random class. So the type of our variable is random with an uppercase R because it's an object. So random generator, or whatever you want to call it, I usually just call it rando, equals new random. So we're creating a new random object. We don't need to put anything in there yet. We can then use this same object to create as many random numbers as we want, but we need to call a method on that random generator in order to get it. The method that we're going to call is nextInt, or there's a couple other ones, but nextInt. So nextInt is going to give us a random number, but a very large one, somewhere between like negative 2 billion and positive 2 billion or something. It's a very large number. And that's going to be our random number, or random num in this case. And so you get this thing, it's kind of nice. So nextInt actually has an optional parameter that you can use. So I can actually pass a number. And if I pass a number, what it essentially does is it takes that big number and it performs a mod operation on it. If you remember mod, that is the remainder after division, like floor division, basic 3rd grade division, not 6th grade division, right? So here, what I'm going to do is divide by 100 and take the remainder. Basically, I can think of it, if I put 100 in, I'm not getting a random number between 1 and 100. I'm getting a random number between 0 and 99. If you actually do want it between 1 and 100, you just have to add 1 to that number, right? Makes sense. Random number between 0 and 99. If you add 1, you'll always get a number between 1 and 100. which is good because if you're developing like a guessing game, nobody ever says, hey, guess a random number between 0 and 9. No, guess a random number between 1 and 10, right? Like it's, anyway. So this is how you would generate a random number using nextInt. Just put in the sort of limit that you want for it and then add 1 if you have a need. By the way, there's also nextFloat, nextDouble, these methods, but they don't produce a large random number. They actually produce a random number between 0.0 and 1.0. So you're basically just getting the bits after the decimal point, and you're getting them with varying levels of precision because it's a random number generated float. But that can be helpful if you're looking for percentages or something like that. You can sort of generate random percentages or the decimal that you would then convert to a percentage. You know what I mean. Regardless, here is an example of the program sort of being used as whole. I've imported my random utility. I then have created a random number generator using that new random with the function call thing there, just like we do for scanner, except that we're not tying it to anything. So that the constructor for a random object does not take any parameters or arguments. Then we can generate an actual random number using the nextInt method on our random generator. We can do that as many times as we want. At this point, we're just going to generate random numbers every time, and then we can display the random number however we want. So that's how you do it. I'll do a really quick demo. All right, I have pre-written a little program here using the random number object. And so here you can see at the top, I've got my import java.util.random. That's going to allow me to use random objects in my program. And so I'm going to start by creating a random object. I'm going to call it dice. I am implementing sort of a very basic little attack roll sort of a thing from Dungeons and Dragons or a similar game. So here I'm going to create a random object called dice, just using new random. This doesn't need to take anything. And now I've got a random number generator that I can use. My object is called dice. And I can use that object to call methods on it to generate random numbers. Do some basic stuff. I got Goblin Armor class is 15, which is actually a lot higher than I remember it being, but that's fine. It's the game. It's a Goblin. The classic. So 15 is the number we got to try and hit with our D20. So here I've got an attack roll. This is just an integer, but I'm going to use my dice to generate a next integer with a bound of 20. So that's going to give me a random number between 0 and 19. Remember, it's using that bound as using the mod operator. So I'm getting the remainder after integer division. And so I'm going to add 1 to that so that I actually get it to be between 1 and 20. But this nextInt generates a random number. Every time I run this program, it's going to be a different number. I'm going to have a different attack roll. I have no idea what it's going to be every time I run it. I also want to note right here where it says bound, you don't actually type that. That is IntelliJ trying to help you out with certain functions. So here, this is a version of nextInt that doesn't take anything. Remember, it gives me a very large number. But I can actually use that optional parameter to send an argument to this method. So the argument I want to send is 20. That's going to be the bound. And then it puts that label in there for me automatically. You don't have to type that. If you do try to type it, Java won't know what it is. But it's just IntelliJ trying to help me out. That can be really helpful for methods that have multiple things, like if you're trying to calculate, compound interest. Do I know, does the principal go first, or does the interest rate go first, or does the rate of compound go first? Like, it would put little labels in so you would see if you were putting stuff in the wrong order. It's helpful, but just know you don't have to type it. If it's grayed out like that, it'll do it for you. Then I'm assuming you don't know the game Dungeons and Dragons. There's no reason you should. But anyway, so I have an attack roll. I'm rolling my die 20. To that, I can add my strength bonus. I've also got weapon damage here. This is not necessarily weapon damage. This just means that I'm using like a long sword, which I would roll a 1d8 for my damage. Then I can say, hey, if attack roll plus strength bonus is greater than or equal to the Goblin's armor class, I hit. So if I hit, that means I can calculate damage. Damage is going to be, I'm using dice. It's the exact same random number generator. Don't need to create a new one, right? NextInt, and then I send it the weapon damage, which is the type of die that I would use. So 1d8 damage for a longsword, plus 1, because I don't want between 0 and 7. I want between 1 and 8. Like an 8-sided die has sides for 1 through 8. And then I add my strength bonus to the damage as well. And then I can say you hit the goblin for blank points of damage, and then I just put whatever damage was calculated into that placeholder. Over here, I've got an else. So else, you swing your weapon at the goblin only to see it dance past your blade. How embarrassing. There's a couple things going on here, especially with this one, because this is a standard print line, and it looks really ugly. You don't need to do it this way. I'm using concatenation just so that I don't go off the edge of the screen, because I have that really big font for recording, so you can see things clearly. And in addition to that, I didn't want it to be too long down here where it went off the edge. So I'm using these special characters. They're placeholder character, or not placeholders, but they're called escape characters. They start with the backslash, which is the one above your enter, not your forward slash. But backslash in is the new line character. So it's a specific character. It's what happens when you press return or enter when you're typing in Word or something. It just drops it down to the next line. And so what this will do is in the actual output, it will drop it down to the next line. Remember, hitting return out here just adds white space, which does nothing, right? This is actually the character that will drop something down to the next line in the console. And so that sort of formats it so it looks nice down here. Now I'm just going to run this. I happened to run it last time, and I happened to hit the goblin for 5 points of damage, although more than likely I'm going to miss the goblin. And so I hit the goblin for 12 points of damage. Ooh, that was a good one, because, I mean, modifier 4, I actually rolled an 8 on damage. So that's good. If I'm here again, I'm going to hit that button, and we're going to hit the goblin for 9 points. Okay, I should go to Vegas right now. I should miss more often than not. So here we go. You swing your weapon at the goblin only to see it dance past your blade. How embarrassing. Little things in the formatting. If it doesn't look right, just kind of go up here and check. Notice I put a space here so that I had a space before the word goblin. Otherwise, those two words would bleed together. The new line, even though it's not exact, I wish I just had a little bit more space over here. It would have been fine. But that's where the new line character happens. It doesn't really matter where you break this with concatenation. That doesn't do anything. The thing that drops it down is the new line character. And so you can kind of see it formatting there. There we go. I have a random number generator that I'm using to create a bit of a game mechanic in my program. Random dice equals new random. That creates my new dice object that I can use to generate random numbers. I used it here to generate an attack roll with a d20. I also used it over here to use weapon damage to roll damage for a successful attack. And then whether or not I hit or miss, I mean, that depends on what actually happens at runtime. I don't know what's happening. I just have to roll the dice by pressing play. Hey, I hit the goblin again. So I'm doing incredibly well. You can do the math. I should be hitting less than half the time. So anyway, that being said, random number generator. Yeah, that should be everything that you need for this week and a little bit for next week, or if you're taking the condensed class, the second half of this week, in terms of your projects. So hopefully that helped. And if you have any questions, just ask, send me a message in Canvas. I will see you online.